Look up at the night sky and you see calm points of light. But galaxies are not calm. They are born, they grow, they collide, and they fade. Every galaxy you see is moving through a life cycle that spans billions of years. Welcome to Mattermosaic, piecing together the universe, one discovery at a time. On this channel, we explore science as a connected story. From the smallest particles to the largest cosmic structures, every discovery fits into a greater whole. Today, we follow one of the most ambitious stories written in nature. Not the life of a star, not the history of a planet, but the life cycle of an entire galaxy. From its emergence, after the Big Bang, to its slow transformation over billions of years, this is the story of how galaxies are born, how they evolve, and how they shape the universe we inhabit. Galaxies did not exist at the beginning of the universe. In the first moments after the Big Bang, the cosmos was hot, dense, and nearly uniform. Matter existed mostly as hydrogen and helium gas, spread almost evenly through space. There were no stars, no planets, no structure. But tiny variations in density were already present. Slightly denser regions contained a bit more matter than their surroundings. Gravity amplified those differences. Over hundreds of millions of years, these denser regions pulled in more gas. Dark matter, which does not emit light but exerts gravitational influence, played a crucial role. Vast halos of dark matter formed first, acting as gravitational scaffolding. Ordinary matter fell into these halos, cooling and collapsing. This marked the birth of the first protogalaxies. Inside these early structures, gas clouds grew dense enough to ignite nuclear fusion. The first stars were born. They were massive, short-lived, and violent. Their radiation and supernova explosions enriched the surrounding gas with heavier elements. Carbon, oxygen, silicon, and iron were forged in stellar cores and scattered into space. These elements would shape every future generation of stars and planets. As star formation accelerated, galaxies entered a phase of rapid growth. Gas streamed inward from intergalactic space, feeding new stars. Spiral patterns began to emerge in rotating disks. Other galaxies formed as irregular shapes, chaotic and clumpy, shaped by frequent interactions with neighbors. In this youthful stage, galaxies were bright, active, and turbulent. Gravity ensured that galaxies did not evolve in isolation. Over time, they approached one another. Some passed close enough to exchange material, others collided outright. These events were not sudden crashes, but slow, cosmic dances lasting hundreds of millions of years. When galaxies merged, their stars mostly passed by without colliding, but their gas clouds compressed, triggering bursts of star formation. At the centers of many galaxies, another transformation occurred. Gas funneled inward toward the core, feeding supermassive black holes. These objects, millions or billions of times the mass of the Sun, grew alongside their host galaxies. When actively accreting matter, they became luminous, active galactic nuclei, releasing enormous amounts of energy. This energy could heat surrounding gas, or even drive it out of the galaxy, regulating future star formation. As galaxies matured, their growth slowed. Gas supplies became harder to replenish. Some galaxies continued forming stars steadily, like the Milky Way. Others experienced dramatic shutdowns. Star formation faded. The galaxy reddened as short-lived blue stars died, leaving behind longer-lived red stars. Astronomers call this process quenching. Quenching can occur in several ways. A galaxy may exhaust its gas. It may lose gas due to interactions with other galaxies or with hot gas in galaxy clusters. Energy from supermassive black holes can also heat or expel gas, preventing it from cooling and collapsing into new stars. Once star formation stops, a galaxy enters a quieter phase of its life. Elliptical galaxies represent one possible late stage. These systems are dominated by old stars and have little remaining gas. Their shapes are smooth and rounded, often the result of past mergers. They are not dead, but they are no longer creating new generations of stars at significant rates. Their evolution becomes slow and passive. Spiral galaxies can also age, though more gradually, their disks thin. Star formation retreats to smaller regions. Over billions of years, even a spiral galaxy may consume or lose enough gas to fade. The Milky Way itself is still forming stars, but at a slower rate than in the past. Its future includes a major merger with the Andromeda Galaxy, expected in about 4 to 5 billion years. That collision will reshape both galaxies. Their disks will distort. Star formation will flare briefly. Eventually, they will settle into a single, larger elliptical galaxy. This is not destruction, it is transformation. A new galaxy will emerge from the combined material of two old ones. On the largest scales, galaxies form vast structures. Groups, clusters, and filaments trace the distribution of matter across the universe. These structures influence how galaxies evolve. Dense environments promote interactions and gas loss. Isolated galaxies evolve more quietly. The life cycle of a galaxy is shaped not only by its internal processes, but by its cosmic neighborhood. As the universe continues to expand, another change unfolds. Galaxies drift farther apart, gas becomes more diffuse, star formation across the universe declines. Astronomers observe that the peak era of star formation occurred about 10 billion years ago. Since then, the universe has been gradually growing darker as fewer new stars are born. In the far future, galaxies will continue aging. Stellar populations will grow older. Some stars will collapse into white dwarfs, neutron stars, or black holes. Occasional mergers may still occur within bound groups, but beyond those regions, galaxies will recede beyond observable reach. The cosmic era of galaxy formation will slowly give way to an era of quiet evolution. The life cycle of a galaxy is not a simple story of birth and death. It is a story of change driven by gravity, energy, and time. Galaxies are shaped by invisible dark matter, by the life and death of stars, and by encounters spanning millions of light years. They recycle material, transform structure, and influence everything within them. Understanding galaxy evolution helps answer deeper questions. Where did the elements of life come from? Why does the universe look the way it does today? How did complexity emerge from near-uniform beginnings? Every galaxy is a record of cosmic history, written in stars, gas, and motion. When we study galaxies, we are not just observing distant objects. We are reading chapters of the universe's autobiography. Our own existence is tied to these processes. The atoms in our bodies were forged in stars that lived and died inside galaxies long before the sun was born. This is Mattermosaic, piecing together the universe, one discovery at a time. If this journey through the life cycle of galaxies expanded your view of the cosmos, support the channel by liking the video and subscribing. Your engagement helps these science stories reach further. Join us as we continue exploring how the universe evolves, from the smallest particles to the largest structures in space.